Let's test another finite state machine. This is another one. This one's very neat, easy to read. It doesn't name transitions properly, however. It only has names for states. And again, Goblin enters, for example, that's the name of a transition. So that should be text over an arrow, indicating that that's a transition. It's not a state. But let's start. Leprechaun, really that's idle or stand guard. I'll note now that this whole thing is a lot more complex than it needs to be. And we see that right away here. No goblin doesn't need to be a transition. The goblin stands guard. He doesn't wander around. When the goblin enters, the leprechaun does something, and that's the only transition that you need from his idle state or his stand guard state. If there's no goblin, if the leprechaun, let's say, spawns, and there is no goblin, then the leprechaun begins to wander around according to this finite state machine. And he never does anything else because there is no transition from this state. So if the leprechaun spawns and the goblin enters, and the goblin throws a rock, he hits the goblin runs out, and the leprechaun goes back to wandering around. Of course, as we mentioned, he'll never do anything else because of the way this is set up. Another possibility that's not taken into account here is that if the goblin were able to transition back to his idle state so that he could be provoked into action, transitioned into action, into rock throwing by the goblin showing up, if he hits 3 goblins in a row, he's out of peas, rocks in this one. His pea shooter is empty. So as long as he misses, as long as he hits 3 times, he'll get to this point and he has no rocks to throw or peas to shoot. So if the goblin throws a rock, leprechaun throws a rock and misses a goblin, he doesn't check his inventory. The only transition that you need here is if he throws a rock and misses, that transition can be, that arrow can be a loop. He continues to throw rocks. Another transition, however, is to what happens if he's out of peas. So there should be a out of peas transition from throws rock, and so that anytime he throws a rock, there's the possibility that he's out of rocks and he goes to the pea bag. Here we have the goblin checking the leprechaun checking his inventory, finding that he has rocks, and returning to throwing. Okay, that sort of that test will be taking place, but that's something a transition can do. If you've ever worked with finite state machines, if you ever get the chance to work with a finite state machine, you'll find that that's the kind of test. That's exactly what the system is doing. And if the system sees that the leprechaun is out of peas, that will cause the transition to a reload state. So he goes to the rock pile. If there are rocks, and again that's a transition, that's not a state, then he reloads and goes back to throwing rocks, except, okay, in this case he's missed. It'll pay to keep in mind that what you should really do here is go back to the idle state, and the leprechaun can then test to see if there's a goblin present, at which point he'll throw a rock. Because in the situation I've described, he can transition after throwing a rock to a reload state, whether or not he's hit the goblin. If there are no rocks, then the leprechaun vanishes. That's good. So yeah, simplify this and fix the places where it comes to a dead end, and test it again. Keep doing that until you find no problems, and everything is as simple as it can be. The fewest possible states with the fewest possible transitions.